In question 4, we have to simplify each of these 7 expressions that you see here. So let's start with the first part. In the first part, we have this expression a square minus b square whole square. So this is of the form x minus y whole square, where x is a square and y is b square. And we can expand this as x square minus 2xy plus y square. So let's apply this identity to this expression. So the expression is a square minus b square whole square. Okay, so we will now expand this. So we will get x square, or the square of a square square, and then we will get minus 2xy, so minus 2 into a square into b square, and then we will get plus y square, so plus the square of b square, like this. Alright, now a square is a to the power 4. Then we have minus 2 into a square into b square, so that's minus 2 a square b square, and then we have b square square, so that will be b to the power 4. So this is the simplified or expanded form of the expression in part 1. So this completes part 1. Next we come to part 2, in which we have this expression 2x plus 5 whole square minus 2x minus 5 whole square. Now this expression can be simplified in a very interesting manner. Instead of expanding these two parts separately, we can note that this whole expression is of the form a square minus b square, where a is 2x plus 5 and b is 2x minus 5. So this whole expression is of the form a square minus b square. So a is 2x plus 5, so we have a square, and then b is 2x minus 5, so we have minus b square. And we know that a square minus b square can be written as a plus b times a minus b. So let's apply this observation to simplify this expression. So we have 2x plus 5 whole square minus 2x minus 5 whole square. So we factorize this as, or we simplify this as, we write it as a product of a plus b and a minus b. So a plus b will be 2x plus 5 plus 2x minus 5. So this will be the bracket a plus b. So 2x plus 5 and then 2x minus 5. So this will be a plus b. And to make sure that you're understanding this, I will write a and b below these brackets. And then the second factor will be a minus b. The second part of the product will be a minus b. So let's write that also. A minus b will be 2x plus 5 minus 2x minus 5. And this whole thing will be the second part of the product. So 2x plus 5 a, 2x minus 5 is b, so a minus b. So the first part of the product is a plus b, the second part of the product is a minus b. And now we can simplify this quite easily. From the first bracket a plus b, we will get 2x plus 5 plus 2x minus 5. So let's open the brackets. 2x plus 5 plus 2x minus 5 into, from the second bracket we will get 2x plus 5, and then we have minus 2x, minus of 2x minus 5, which will become minus 2x plus 5. The sign of minus 5 will get inverted as plus 5. So now from the first bracket, we have 5 and minus 5 cancelling out. So we have 2x plus 2x, so that's 4x from the first bracket. And from the second bracket, we have 2x and minus 2x cancelling out. So we have 5 and 5, which is 10. So we get 4x into 10. And this is simply equal to 40x. So 40x is the simplified form of the expression in part 2. So this completes part 2. Now we come to part 3. In part 3, we have the expression 7m minus 8n whole square plus 7m plus 8n whole square. So the first part of this expression is of the form a minus b whole square, where a is 7m and b is 8n. So a minus b whole square can be expanded as a square minus 2ab plus b square. and this is how we will expand the first part, 7m minus 8n whole square. The second part is of the form a plus b whole square, where a is 7m and b is 8n. So we can expand this using the identity a plus b whole square is equal to a square plus 2ab plus b square. Okay, now let's apply these identities and simplify this expression. So we have 7m minus 8n whole square plus 7m plus 8n whole square. So let's expand the first part. 7m minus 8n whole square will be 7m square minus 2ab, so minus 2 into 7m into 8n, and then we have plus b square, so plus 8n square. And then we expand the second part, 7m plus 8n whole square, so this will be 7m whole square or a square plus 2ab, so plus 2 into 7m into 8n, and then plus b square, so plus 8n whole square. Alright, now let's see what we have. So we have 7m square, which is 49m square. Then we have minus 2 into 7m into 8n. So this is minus 112. So 2 into 7 into 8 is 112. So we get minus 112 mn. And then we get plus 8n whole square, which is 64n square. Okay. This is from the first three terms, and then from the next three terms we have 7m whole square, which is 49m square again. Then we have 2 into 7m into 8n, so this will be plus 112 mn, and then we have plus 8n whole square, which is 64n square. Now in these terms that we have obtained, the mn terms cancel out, so we have minus 112 mn and plus 112 mn. These two terms cancel out. We have 49m square plus 49m square, so this is equal to 98m square. And then we have 64n square and 64n square. These two terms add up to 128n square. So the simplified form of the expression is 98m square plus 128n square. This is the answer for part 3. Next we come to part 4, in which we have the expression 4m plus 5n whole square and 5m plus 4n whole square. So two parts in this expression. Both the parts are of the form a plus b whole square, and a plus b whole square can be expanded as a square plus 2ab plus b square. So this is the identity we will use to expand both the parts in this expression. Okay, so we have 4m plus 5n whole square, and then the second part is 5m plus 4n whole square. Now let's expand the first part, 4m plus 5n whole square. This will be 4m whole square plus 2 into 4m into 5n, 2ab, and then we will have 5n whole square. So this is the expanded form of the first part. And now let's expand the second part, which is 5m plus 4n whole square. So this will be 5m whole square plus 2 into 5m into 4n, and then we will have 4n whole square. Alright, now let's simplify this. So we have 4m whole square, which is 16m square. Then we have 2 into 4m into 5n. So 2 into 4 into 8 is 40. So we get 40 mn. Then we have 5n whole square, which is 25n square. Then we have 5m square, which is 25m square. 5m whole square is 25m square. Then we have 2 into 5m into 4n. So 2 into 5 into 4 is again 40. So we get 40 mn again. And finally we have the term 4n whole square, which is 16n square. Now we will collect the like terms. So we have 16m square and 25m square. This totals to 41m square. Then we have 40 mn and 40 mn. This adds up to 80 mn. So we have 80 mn. And finally we have 25n square plus 16n square. This adds up to 41n square. So the simplified form of the expression is 41m square plus 80mn plus 41n square. This is the answer in part 4. Next we come to part 5, in which we have to simplify the expression 2.5p minus 1.5q whole square minus 1.5p minus 2.5q whole square. So this part is similar to part 2 in the sense that this expression is of the form a square minus b square, where a is this expression 2.5p minus 1.5q and b is this expression 1.5p minus 2.5q. So the whole expression is of the form a square minus b square, where a is this expression inside the box and b is this expression inside the box. And we know that a square minus b square can be written as a plus b, a minus b. So this is the identity we can apply to simplify this expression. So a, as I said, a is equal to 2.5p minus 1.5q, the expression inside the first box, and b is equal to 1.5p minus 2.5q, and the whole expression is of the form a square minus b square. So we can simplify it by calculating a plus b and calculating a minus b separately and then multiplying the two. So let's calculate a plus b separately. So a plus b will be equal to 2.5p minus 1.5q, this expression, plus 1.5p minus 2.5q. Okay, so 2.5p plus 1.5p is 4p, so we get 4p, and then minus 1.5q minus 2.5q is minus 4q. So a plus b we get as 4p minus 4q, 4p minus 4q. And similarly, let's calculate a minus b now. So a minus b will be 2.5p minus 1.5q, that's a, and then minus 1.5p and minus 2.5q. Okay, now let's find out the value of a minus b. So we get 2.5p minus 1.5q, and then from this part, minus of this bracket, we will get minus 1.5p, and then this minus and this minus will become plus, so we will get plus 2.5q. Okay, and now this will give us 2.5p minus 1.5p is p, and minus 1.5q plus 2.5q is plus q. So we will get p plus q. So a plus b is 4p minus 4q, and we can write 4p minus 4q as 4 times p minus q, and we get a minus b as p plus q. So finally, remember what we have to do. We have to multiply a plus b and a minus b. A plus b we obtained as 4 times p minus q, and a minus b we obtained as p plus q. If we multiply a plus b and a minus b, we will get a square minus b square, which is the original expression we wanted. A square minus b square, which is this whole expression that we are trying to simplify. So a square minus b square will be a plus b, so 4 times p minus q times a minus b, which is p plus q. So p minus q times p plus q, again we can use this same identity to simplify this. So this will be equal to 4 times p square minus q square, and I can, if you want to expand this, you can write this as 4p square minus 4q square. So this is the final simplified form of the original expression, 4p square minus 4q square, and this is the answer for part 5. So this is a slightly trickier question compared to the other parts, so make sure that you have followed it fully, and if you have not, I will urge you to pause the video and go through it a couple of times till you have understood it fully. Now we come to part 6, in which we have to simplify this expression ab plus bc whole square minus 2ab square c. So the first part, ab plus bc whole square, is of the form x plus y whole square, where x is ab and y is bc. So x plus y whole square can be expanded as x square plus 2xy plus y square. So we can apply this identity and simplify the expression in part 6. So let's do that. We have ab plus bc whole square, and then we have minus 2ab square c. So let's expand this part using the identity that we discussed. So we will get ab whole square, which is x square, plus 2xy, or 2 into ab into bc, and then we will get y square or bc square, and then we will have the second part, minus 2ab square c. So minus 2ab square c. Now let's simplify all the terms. So we have ab whole square, which we can write as a square b square. We have 2 into ab into bc. Now in this product we have 2 repetitions of b. So we will get 2a b square c. So make sure that you've understood this product. 2 into ab into bc will be 2a b square c. Then we have bc whole square, which will be b square c square, and then we have minus 2a b square c. And now in these terms we see that the second term, 2ab square c, and the fourth term, minus 2ab square c, these two terms cancel out, and we are only left with a square b square plus b square c square. So this expression is the simplified form of the expression in part 6. So part 6 is done. Now let's do the last part, part 7. In part 7, we have to solve or simplify this expression, m square minus n square m whole square plus 2m cube n square. So the first part of this expression is of the form a minus b whole square, where a is equal to m square and b is equal to n square m. So a minus b whole square can be expanded as a square minus 2ab plus b square, and this is the identity we will use to simplify the first part, expand the first part. So we have the expression m square minus n square m whole square, and then we have plus 2m cube n square. So the first part we expand using the identity we discussed, a minus b whole square. So we get m square whole square minus 2ab, so minus 2 into m square into n square m, and then b square, so n square m whole square, and then we have this last term plus 2m cube n square. Okay, now let's simplify the terms. So m square square is m to the power 4, and then let's look at this product, 2 into m square into n square m. In this, m square and m will give you m cube, and you have n square. So we have minus 2m cube n square. Okay, next we have n square m whole square, which will give us n to the power 4 m square. So n square m whole square will give you n to the power 4 and m square. And finally you have the last term plus 2m cube n square. So in these terms, the second term and the fourth term cancel out, they are negative of each other, and we are left with only m to the power 4 plus n to the power 4 m square. Okay, so this expression that we have obtained, this is the simplified version of the expression in part 7. So with this we have completed part 7, and we have finished question 4.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.